participate in that regard. Bill unmuted, so I think he's got a comment.
Nope, no. Just ready. Just ready.
Okay.
I do post on 4th 2020 and the other 4th one, primarily the challenges, but it gives the access information. And then yesterday I put down also access information.
That's cool, and encourage them to come and present to us. But also suggestions for topics, maybe even without presenters. Like, I'd like to hear a good talk about X, Y, or Z. And maybe we can put that out and somebody will say, oh, I know all about that. And they'll come forward and give a talk. That might be a useful way to incite presentations. The topic I had that I wanted to ask you folks about is merch. I think we seem to have grown bored with t-shirts. I'm wondering, is there a market for little swap dragons? If you guys are interested, maybe we can continue to chat in the chat dialogue. I was thinking coffee cups. Coffee mugs are pretty, I'd like to say, easy for some enterprising young guy to sell. If anybody is interested in that, please contact me. And finally, thank you, Bill, for your patience. One more thing I'd like to bring forward is that we still have this this vast pile of maybe half to 3/4 of what we brought down from the Mountain View Press, Glen Hayden Hoard. I've been throwing stuff in the paper recycling at the rate that I can. It tears my heart out to throw copies of Starting Forth. If anybody wants a case of Starting Forth to sell and is willing to pay me the shipping cost or would like to pick it up, let me know. Contact me. We'll move forward with that. Unfortunately, life has intruded in plan to liquidate that stuff on a more timely basis. So if you'd like to participate in the rent for that storage locker that we're using, please contact me. If you've already contributed this year, please disqualify yourself. But yes, I would like your money. I can be bought $185 a month or fraction of that. And please, nothing in excess of 1 month for anyone to please. I would like to encourage you, PayPal or send me a check, contact me. Once again, arthur@comcast.net. All right, that is the limit of my blather. I will now get on with the show. Bill Ragsdale has this month's challenge.
Very good. Thank you. Thank you, Kevin. And Klaus, thank you. That work is beyond impressive. That for results that are real and practical, it is breathtaking. Thank you. All right, our challenge today is to develop a list of target words for the game Wordle. From those target words, develop letter frequencies. So it's the old ETAONISH frequency as a toolkit. Do we have any people who are interested or are willing to present today?
As you recall, I was fairly close last time, so I made some small revisions to what I did last time. I can talk about that briefly.
Very good. Brad is in the pipeline. Anyone else, please? All right, Brad, take it away. The floor is yours.
Unmute Brad.
I can't hear Brad. Brad needs
Well,
to unmute.
let's try that again. Sorry about that. Backing up. One fun thing is that last time and this time I've been able to use my own forth for this, the micro eForth, which is the Linux version of ESP32 forth, and that's been kind of fun to use one's own forth for these challenges. So as last time, I used the Unix dictionary and just pull it into memory using the standard file ANSI file words that I support. So just in a giant buffer in memory. Unlike last time where I didn't particularly pay heed to upper and lowercase letters, this time I decided to go through and uppercase everything and used my favorite trick that I picked up out of eForth, which is the ANDing with 95 to move things to uppercase if you happen to know that things are in a certain range and to contain certain characters. So I just go through and do that to the entire buffer. And then I have a set of iteration words to be able to step through the looking for new lines to find boundaries between words. And then this each brace syntax that will let me walk through a word list, leaving the address and length, so the counted string, or sorry, what do you call those? The two, the string address and length form. There's a term for that, right? Anyways. I then, as before, build up a set of letter frequencies, just counting them into 256 slots. And then I've got, and I'm counting these, by the way, I'm counting both the total and the individual counts so that I can do everything in integer math. I then have a word to help me print in fixed point, and then print out the table for the alphabetical characters. I've added a word to check to see if something is a letter, and then to check for a string to see if the string contains only letters. And then I can then walk through, build up my table of frequencies, and then walk through all the words again, looking for the ones that are 5-letter, that have 5 characters and which are all letters. In that case, I print them. I print their frequency. Otherwise, I drop them. It happens that the Unix dictionary file is in sorted order, so I get out word frequencies, followed by 6,112 5-letter words. I've grabbed the top of them and the bottom of them here. And are there any questions? Stunned silence. Back to you, Bill.
Very good. Thank you, Kevin. Thank you. And I shall jump in here.
That was Brad.
Oh, I'm sorry, Brad. Mental typographical error happens all the time. I type faster than I can think, and I think faster than I can talk. So this is our Wordle exercise number 2. Wordle has made a major impact on our social structure. Every morning at 8 o'clock, as I am getting up and shaving, my phone goes beep, beep, and my wife has just solved Wordle and sent me her solution. And then her sister and her sister-in-law and 3 neighbors all round table on sending Wordle to their friends. We don't get to see the answers. We just get to see the structure. So the Wordle game, I'll briefly review it. It's put out now by the New York Times. The fellow that invented it is British, and he got $1 million plus for the game by the New York Times about 4 months ago. And the basis of it is to guess a 5-letter word, and it changes there's a list of 3,500, and every day the app pulls out the next word for the day and then guides you searching for a solution. So you're trying to guess what the 4-letter word is. You pick a starting word, like a lot of people like the word audio for a first letter or first word. And then you have 6 tries to guess the word, and you get clues along the way. Every time you get a correct letter, the letter will be shown in gold, but it does not show you where it is. It just confirms that it is in use. And then if you have guessed the correct letter in the correct position, it shows up in green. And so pretty soon you have a game of elimination because you know where letters are not supposed to be used. And this is a typical solution. One of the words I use at the start is ridge, R-I-D-G-E. In this case, I caught I-D and E, then I went to doggy, and I caught the D, and then I go to diode, and it shows me the DE are in green, which is quite a help. And then I go to oxide, which is the 4th word. So the main challenge is built on this. We're sort of working toward a toolkit on Wordle. So our first element is to develop a list of the words. Some number of list of words. What I've done is I've extracted from the New York Times application the entire list. So I'm working with the full list, which is about 12,000 words. And at the end today, I'll show you how to extract that word set. So from that word set of the actual words in use, determine the letter frequency of each letter across all those words. Of course, E is going to be the most used and T is second most used and so on. And then finally, kind of for extra credit, compare the result to a published source so you can see how close your result is. And this is the actual word set. This is a part of the dump where I'm doing a select on the actual words from the app from the New York Times. This is extracted from my Foxfire cache. So we need a number of initial parameters. I'm doing file access, so I need to have the file name, the file handle or file ID number, the file size, a buffer for its contents, and then a variable that holds the total number of letters. So this creates the file name. Actually, no, I have file name created. And then I note here and load it into file name. And then I put down a compile string that is the path to the file name. And the file name in this case is Wordle wordlist.txt. Then I determine the file access and store it. I determine the file access and then I create a buffer called my file contents. So this is done by specifying my file access, determining where here is, I swap it, allot that many byte spaces, and then finally load it into my file contents. Now we open up the file. Pretty simple. We use the file handle, the count, and a read-only. Open file, opens the file, gives us a potential error code, which we check with the -280 throw, and with no error, it will be loaded into the file ID, or otherwise file ID or file handle. Then that code you see there copies the file into the buffer. We read file into the buffer, and then we close the file. So now we have the information in my file contents. I create a frequency matrix. In this case, I use my matrix utility tools, and I do a 26x1 matrix, 26 letters tall and 1 character wide. And now here's where the work is done. This is building the frequency table. So the first line says result clear, 0 to total letters. Those are initializing those values to 0. Then my file size 0 gives us the range of characters that are in the text file. And then the do loop scans across the letters in that file. There are about 110,000 letters in the file. You'll see a lot of quote marks and commas, which are skipped over. And every time we reach a 5-letter sequence, the individual letter is determined. It's indexed into that matrix we mentioned a minute ago. And if you see at the line in green, the bracket plus store, that reaches into the matrix in the proper row and adds 1 to it. So we're incrementing the frequency count for each letter as we encounter it. So we ramble along over about 50,000 letters, incrementing as we go. And then the 1 plus 2 total letters accumulates how many letters we've actually processed. So the work is all done there. Everything up till now has just been preparatory, getting everything in memory. This has built a frequency table. Now I want to make a comparison to a standard frequency table. So I went into Wikipedia and found the letters there, starting with 65, which is ASCII A, going down to 90 at the bottom, number 90, which is ASCII Z. And then each of those is followed by its frequency probability. This uses some of the matrix utilities that I showed a year or so ago. And finally, now we get a report. This is the report after all processing's done. There's a little setup on it and the do loop. Inside the do loop, there's a 3 spaces, and we extract the alpha letter and emit it. We skip over 3 spaces and get the total count. Then we get the total number of letters and divide by them. And finally, the last line, 3 spaces, freak table, and so on, is the Wikipedia value. So what and of course, the header along this at the top line says letter, count, frequency, Wikipedia. First column is the letter, the second column is the count, third column is the frequency of that letter, and then finally the Wikipedia value. And here is the final report. Interesting facts on this. You can see in red the letter E had 6,653 occurrences, and its frequency is about 10%, 0.103. Comparing to Wikipedia, it's 0.110, very consistent. You see letter Q in red in the second column. Only 112 occurrences of Q. It is 0.2%, and Wikipedia has the same 0.2%. Now at the bottom, something that absolutely fascinated me. At the bottom right is the total elapsed time for this. It's the loading, the sorting, and the reporting is 0.2 seconds. Unbelievable to me. All of that's done in 0.2 seconds. Imagine if you're going to do a frequency table of 65,000 letters, 65,000 letters, it would probably take you 2 days, maybe, doing it by hand, 65,000, at least several hours to do it. And here the good old computer does it in 0.2 seconds, 200 milliseconds. On the bottom right, we see the total number of letters processed is 64,000. Total number of words is 12,947. Wordle has 2 word lists. One of them are the words that they will use in the quiz, and there's a second list, which are words that do exist in the dictionary but will not be used in the quiz. They are a lot of the rare words like SVFIG and things like that. There are no proper nouns in the word list, and there are no words that are just a straight duplicate. So these are non-plural. So if you have a word like top and tops, it will not show up because it's a plural. So there was my final report for the quiz. And here are my discoveries from the activity. Since short words do not appear on the list, words like a, and, the, of, to, and for, those do not appear on the word list, and they tend to be vowel heavy. So if anything, my analysis compared to a regular English language would underrate vowels somewhat. But of course, they do precisely reflect the actual words used in Wordle. This is the first time I've actually done heavy use of file access in Win32.4, and I found that due to some sort of changes over time, a few of the words don't work. File size and Win32.4 does not currently work on Windows 10. I have a few guesstimates on why that might be. So I corrected the word, and now I have file size that does work. And finally, the matrix tools help greatly. I got into the point of either report writing or clearing or initializing, and I started to write words to do that. And then I realized, no, they're already in the word in my matrix toolkit. So that helped quite a bit. Now this brings us to the June challenge. June challenge. So in this case, we start with a letter word list the same way. And again, the Wordle list is some 12,000. But now what we want to do is find an evaluation criteria for closeness. What this means is you take two 5-letter words and how close are they to one another? If a letter is not in comma between them, then that would add 0 to the closeness. And then if letters match in position, you have another closeness factor. And if they have common letters in use, there's another one. What we want to do is do an n-squared commonality. Against all words, compare the commonality to all other words, and then sort the result. What this will do is bubble up to the top the words that have the most commonality with the most other words. Again, people use words such as audio, which is by a rule of thumb, has a lot of vowels and seems to work well. So just as a matter of curiosity, we're looking for what are the words that would have the best commonality to other words. And here's how that is done. The key thing for you all to remember as you embark on this is in your browser, and particularly Foxfire, in the search window, put about : cache. What this will do is go into Foxfire and give you access to cache memory, non-encrypted. So I suspect it probably will work on other browsers. I haven't tried it, but anyway, about : cache. It will bring up a window, and in this you have files that are in RAM and files that are on disk. From the disk portion, you select list cache entries. This will get you to a list of all the cache entries that are currently on file, and then do a Control-F search and find Wordle. Somewhere along the way, you'll then see the New York Times Games Wordle. And at the right hand, we see there are 97,000 bytes, which is the file size. And that is it. If you click on it, it will bring up this cache entry information. If you click on that, you will get the file. So if you do a select on this into a text file, you can extract the two word lists. And of course, they're in a .txt format with quotes and commas, as you would expect. So this is a head start for next month's quiz. Are there any questions? I see we are all in stunned silence, which is appropriate after such a dramatic presentation. One last chance for any questions, and I do invite you. My email address is bill@billragsdale.cc. bill@billragsdale.cc. In case you forgot, .com will also work. Kevin, did you have a comment?
I was wondering if you would be so kind as to email me a copy of the slide with the next month's challenge so that I can include it in the meeting announcement for next month's meeting. It is almost always the first thing on this that gets posted in the preliminary meeting invitation on.
I certainly will. As a side note to what I just talked about, it's the first time I've really done large data arrays and file access. And it's really amazing when you have a force system that just absolutely performs at high speed, convenient, quick, clean. Lack of documentation is a problem, but I have written an 85-page book on Win32 and one of these days it's going to be widely available. So back to fearless leader Kevin. Thanks so much for your kind attention.
I think that if you're interested in that book, you can probably have a preview online. Bill, would you care to post the URL in the chat?
I shall. It's an earlier version is available right now. And I'll put a link up currently on it. It's on my GitHub. It's about a 3 months old version, and I'll try to update it from the latest. And as you all will see on this, is strictly a work in process. It's a raw manuscript, and there are comments and questions to myself, but it is amazingly complete. It is really good. So I'll post it.
One of the things I always propose to speakers is introduction to your programming language or your implementation of Earth or your whatever for the feeble-minded beginner. And it's always a talk that I enjoy. So talks about getting started with Win34th or whatever, always useful and instructive to the feeble-minded participants such as myself. Thank you so much, Bill, for your continuing participation, and in particular for the May Challenge. And I'm looking forward to June. So, Don.